Leetcode 1043, partition array for maximum sum. The description, unfortunately, is a little bit unclear and confusing, at least for me. But after some digging, I think I understood it myself and can make it a bit easier for you. So let's try and let's start. Given an integer array R, that's our input, partition the array into contiguous subarrays of length at most k. Yeah, so we have to divide the input array into subarrays, and the length of them is at most k, and that means that they can have varying length. Yeah, so it's not clear how many subarrays you should have. You have to somehow in your algorithm came up with the best way to create multiple subarrays out of your array, and the constraint for them is that their length has to be at most k, but they, for example, can only they could contain one element, and so on. So let's read further. After partitioning, each subarray has their values changed to become the maximum value of that subarray. And that's also really strangely written, but what they mean is that when you decided on your subarray how long it is, where it starts, where it ends, then you change the values of each element inside that subarray to the value of the one that has the maximum value. Yeah, so you find the maximum inside that subarray and change all the others to match the maximum. And after you did that, you have to return the largest sum of the given array after partitioning. So after you first decided on your partitions and your subarrays, you changed all the values to the maximum value within given partition. Then you have to sum values across all the partition, and this accumulated sum is our result. Test cases are generated so that answer fits in a 32-bit integer, and that's something that might be useful in other languages like C++, but for Python we are not taking advantage of that information. So here is the first example. We have following array: 1, 15, 7, 9, 2, 5, and 10, and the maximum length of our subarray is 3. And the output is 84, and that's what they did. So let's try to copy it and see what has happened. And that's the array, and that's the output. Yeah, and what they did, they divided it into following subarrays. That's a bit too thick. Here is the first one. Here is the second one. And here is the third one. So they divided it into the following subarrays. And the first partition, so partition 1 was called like this, is originally 1, 15, and 7. Bigger. Let's put it here. And here is the second partition. Partition 2 is just 9. And partition 3 is 2, 5, and 10. And then in each partition, we have to find the maximum. So here is the maximum for the first partition, the second, and for the third. And then we need to replace every other value with the maximum, and that's how we arrive here. That goes here, that goes here, and that goes here. It's like multi-step task. And if we sum that, then we should arrive at 84, and that's our sum. So 15 plus 15 is 30, Here we have also 3 times, that's also 30, so 30 plus 30 is 60. 60 plus 15 is 75, and then plus 9 gives 84. That's the answer. Here's the second example. Let's try it out. So here the answer is 83. And k is equal to 4. And before the k was equal to 3. So already I can see that here was one partition, because here we have 9s. Then probably here was one partition, and here as well. Let's check if that's the correct guess. So we would get as an output from that 5, 5, 5, and 5. Here we would get 7, 7, 7. And here we will get 9, 9. Yeah, so let's use calculator for that and see if it matches 83. So 36, 4 times 9, plus 20, 4 times 5, plus 3 times 7, that's 21. And that's 77, so that wasn't the partition they made. So probably they extended 9 on the other side. So the first guess was wrong. So probably what they did is extend this one to the maximum, then this, and then this, like that. Let's try. So we would have 1, then 7, 7, 7, 7, then 9, 9, 9, 9, 9. 9 should be 6 times, yes? Okay, let's try to check. That was it. And I am already seeing an algorithm that we can use. So 1 plus 28, 29 plus 9 times 6, which is 54. And that's 83. So what's the algorithm? We need to find the biggest, always the biggest value, and extend it maximum to the left. Yeah, so here biggest was 9, here the biggest was 9, and here the biggest was 7. Yeah, so we always need to try to find the biggest one in the possible window, and we need to take into consideration all possible windows, and then try to extend it as much as possible, and the same further and further. So we definitely need a sliding window, but how it will slide needs to be decided. Let's start with storing the length of the array in variable n. That's common notation and makes the code a little bit more readable, at least just because it's so commonly used that we don't have to use that length call all the time. And the next thing, we have to store somewhere the max sum, which will contain the result that we are looking for. So we have to find this largest sum of array after partitioning. So we will be going through array, trying different windows of different sizes, and for each element we will store the best sum that was found so far, or the largest sum that was found so far. So we need at least n time, and the last element will have the best sum for the whole array, yeah, because we went through everything already. So in that case, we will simply do n plus 1, yeah, so that we can use n here. And now we need to create those windows of various lengths. Yeah, so it will have a right index, left index, and length, which is the difference between right index and the left index and how big the window is. And right, we can simply start from 0 or from 1, and better from 1 because lengths either way cannot be equal to 0. And we could, of course, add 1 later when we take the length, but I think that's a little bit more readable. N plus 1. And that will be our right index, yes, and we'll be moving it one by one. And we'll be also adjusting the left index in a second. And for any window, we will have to find like max that is best for the given window. Yeah. So that is max for window, and here accumulated largest sum. And now we have to get somehow the left index or the length. Yeah, because right minus length gives a left index. Length in range from 1, because length cannot be 0, to minimum between k and right, because right in the beginning is very small. K could be much bigger, so we cannot have, we don't know which one is bigger, and we have to take the smaller of them, and also plus 1 here. And now we can update current max to be the maximum between current max and the next value, which is value in the array on position right minus length. And so at the beginning, a length is 1, right is also 1, and we have array at index 0, which is the first element in the array, and so on. And we'll be iterating like this. Then the second thing, what do we need to do here? The second thing is that we need to update this as well. So the max sum on position right will be the max sum on position right, and the previous, either the previous one, max sum, sorry, or max sum on position right minus length. So the left index plus length times current max. Yeah, because in the partition itself, in the subarray, all the values have this same value, which is equal to the current max. And because it's accumulated, so we also have to take all the values before to where they end, right minus left. So let's see. That was quick. And let's see here, let's submit for everything. And we beat 87% of other users.